Hello, this is Kyle Glodemans, and for assignment 2, I was going to be doing problem 2 from midterm 1. So we have a homomorphism, phi, that takes g of 0 to g of 1, and this is under multiplication for groups. And so the identity of g of 0 is e of 0, and the identity of g of 1 is e of 1. A homomorphism is a function that sends elements of g of 0 to elements of g of 1. However, it is not an arbitrary function in that it must also satisfy the following property, which is phi of xy is equal to phi of x times phi of y for all x and y in g of 0. And whenever we are given an equation that holds for all values, it is often useful to plug in certain special values. And a simple way to illustrate this is we can take x to equal e of 0 and y to equal e of 0 and plug it into the property above, and we get phi of e of 0. E of 0 is equal to phi e of 0 times phi e of 0. But the left side can be simplified to just e of 0 because it's e of 0 is an identity. So you get phi of e of 0 is equal to phi e of 0 times phi e of 0. Since we know this is a group, we know we can take inverses. So we can take the inverse of phi e to the 0. So we're going to get on both sides. So we're going to get phi e to the 0 inverse times phi e to the 0 is equal to phi e to the 0 times phi e to the 0 times phi e to the 0 inverse. And simplifying this, we get e to the 1 is equal to e to the 1 phi e to the 0, and therefore e to the 1 is equal to phi of e to the 0, and we are done.